Hello, pre-algebra, Mr. Lawrence here with your flipped lesson, and we're going to review some probabilities here. You guys did a great job in class today. I'm very proud of you. Very proud of the people that led us in YMCA 7th period, and I'm a little teapot during 8th period. Nice job, folks. All right, keep it up, guys. Let's have some fun. Let's do some math, but have some fun as we do it. All right, it's almost time to rest. Not yet. Almost. Just keep working a little bit harder. All right, let's take, first of all, the scenario where we have a 20-sided die and a coin. And I want to know the probability of getting an even on the 20-sided die. I'm going to put roll in there. We're going to roll an even. And getting a heads on the coin. Now, and should mean two things to you. One, it's going to be a multiplication problem, right? It will be a multiplication problem. And two, these are two separate events happening. We're going to do the roll of the die, and then we're going to do the flipping of the coin. So today in class, we were just doing like one event when we were doing ORs, but the and is going to be multiplication. So I'm going to do the probability of rolling even on a 20-sided die. Well, I think that would be 10 over 20, right? 10 of the numbers would be even, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, etc. Okay, and then getting a heads on a coin, that would be 1 out of 2. Now before I actually multiply, I'm going to go ahead and simplify 10/20ths to 1/2 and multiply and get 1/4. So there's a 1 in 4 chance that that will happen. If I take a 20-sided die and a coin, I roll the die, and then I flip the coin, it should happen 1 out of every 4 times that the number rolled will be even and the coin will land up heads. All right, now we're going to take the probability of getting a number less than 6 on the 20-sided die, and then a tails. All right, well, how many, excuse me, it should be less than or equal to 6. How many numbers on a 20-sided die are less than or equal to 6? Well, I think there are 6. 6, 5, 4, 3, 2, 1. So 6 out of 20, and means to multiply, and then a tails is 1 out of 2. All right, and means to multiply, and there are 2 separate events happening. I'm going to simplify this fraction down to 3/10, and then I'm going to multiply. 3 times 1 is 3, 10 times 2 is 20, and so we're going to get 3/20. Okay? All right, so this is going to be a quick video. I can tell I'm tearing through it. Next, I have this bag of letters and numbers. A, B, and C are green. D, E, F, 1 and 2 are all black, and 3 and 4 are blue. I want to know the probability of getting a letter and then getting a number. This means there are going to be 2 draws. Now, Marissa Hecker is going to ask me, am I going to put the first number back? I'm going to say no. I'm going to do it without replacement. So whatever I draw the first time, I don't put it back in the bag when I go to draw the second one. How do I know there are 2 draws? Because of the and. It does mean multiply. It also means 2 things are happening. So what's the probability of getting a letter? Well, I see 6 letters up here, and I believe there are 10 total characters. Now, what's the probability of a number? Well, there are 4 numbers, but there's only 9 characters left in because maybe I picked out an F. Maybe I picked out an A. I'm going to simplify and make that 3/5, and 3 times 4 is 12, and 5 times 9 is 45, and it'll happen 12 out of every 45 attempts, the theoretical probability. All right, probability of getting a green or a blue. Ooh, look at that, different word there. First of all, it means it's going to be an addition problem. Second of all, it means only one event is going to happen. All right. Thirdly, I have to stop and ask, is it possible to get a green and a blue with only drawing one time? Let me look up here. Are there any characters in this circle that are both green and blue at the same time? No, there aren't. None of them are green and blue. So this will be an easy problem. I'll figure out the probability of green, figure out the probability of blue, and I'll add them together. All right, so the probability of green would be 3 out of 10. The probability of a blue is 2 out of 10. Why isn't it 2 out of 9? Because I'm only drawing one time. How do I know? Because it's an OR. All right, I'm not going to simplify my fraction. I'm going to add together 3 and 2 and get 5/10, and this fraction I will simplify and it should happen 1 out of every 2 times. Now let me just go up here. Watch this. This is so simple. Sometimes we miss it. How many greens are in the bag? 1, 2, 3. How many blues? 4, 5. How many total? 10. Didn't my fraction before I simplified it, wasn't it equal to 5 over 10? It sure was. Okay, let's look at another example. And this is the one where kids get a little bit confused on, but you guys really did a nice job with it. I'm very proud of you. I was talking to Mr. Underhill and felt very good about what happened on Tuesday in class. Keep up the good work. All right, we need the probability of a black or a number. Well, first of all, I know the or means addition. Second of all, I know there's only one event happening. Thirdly, I have to ask myself, is it possible to get a black number on one draw? Let's take a look. Do you see any black numbers in the bag? I sure do. I see 2 black numbers. These 2 right here are black numbers. They may not look black anymore since I highlighted them in green, but let me get rid of that. They are black numbers. So I'm going to have to subtract on this one. But let me first set it up. Probability of getting a black. Let's see how many black characters are in the bag. 1, 2, 3, 4, 5. So the probability of getting a black out of that bag is 5 out of 10. The probability of getting a number. Well, how many numbers are in the bag? Looks like 4. 1, 2, 3, and 4. Okay. But some of them are black numbers. I don't want to count them more than once. Like if I go count the blacks, okay, the black characters, I get 1, 2, 3, 4, 5. But now if I go count the blues, I get the numbers, I get 1, 2, 3, 4. Notice I counted the 1 and 2 twice. The subtraction gets rid of, how does Goiko say it? I think he says the overlap. Is that what he's calling it? The overlap? Yeah, I think that's the word he likes to use. All right, so I am going to take the 5/10 and 4/10, but I'm going to multiply them together. And that will get rid of the overlap. So 5/10 plus 4/10 is 9/10. Over here, the multiplication, I'm going to go ahead and simplify that to 1/2. I'm going to simplify this 4/10 into 2/5. And I could simplify further, but I'm going to cheat and not simplify. All right? I'm cheating because I know I'm going to get a common denominator. 1 times 2 is 2. 2 times 5 is 10. And that'll equal 7/10. And there you go. This is easy stuff. Feel good about what you're doing, guys. A couple days ago, you thought this stuff was hard and you were frustrated and you didn't get it. You know, Mr. Underhill and I, when we see you not getting it, we're going to help you out. We're on your side. We're going to go, we're going to look at what's going on, and we're going to come back and try to help you in another way. Okay? Now, a lot of you responded very well. You went home, you watched the videos, you talked about it, you came for help, whatever it took, and now you're getting it. I'm really proud of like Omar and Megan and Devin and Josh and Elias and Jaden and some other people too are working very hard on this. Okay? Don't let your attitude get in the way from you being successful. All right? Okay, that's enough of that preaching. Mr. Lawrence signing off. Have a good night, everybody.